Now coming to the optical properties. So as we have learned in the structural properties, in the structure variation, and see here the optical properties. So nanoparticles possesses unexpected optical properties due to the small size and can produce well-defined quantum effects. One example of this is that gold nanoparticles appears deep dark in black solution, deep red to black in a solution. See here, this we have already discussed several times about the gold nanoparticles. So the optical properties, as we have seen from the electromagnetic spectrum in one of the video lecture I've told to you, these nanoparticles possess unexpected optical properties due to the small size reduction and can produce well-defined quantum effects. So the photons, when falls on the particular small sized particle, then from the visible region of the electromagnetic spectrum, we are going to expose, so not we, the gold nanoparticles are going to be exposed and through the different lights. This is what I have previously been explained. Once go through that one. So with the reduction in the size, the optical properties are going to be enhanced. Okay, now coming to the thermal properties. In nanosystems, several factors such as small size, special shape and large interfaces modify the thermal properties, rendering them quite different behavior as compared to the macro scale. See, in previous videos or in one of the video, we have seen the different nanotubes, nanostars, nanoclusters, so many things, nanorods. We have observed so many things. So we can make the several shapes of nanomaterials and with the large interfaces modify the thermal properties. So that the thermal properties means what? The thermal properties means the temperature dependent properties. Okay, the temperature dependent properties have been changing. Right. Now coming to the mechanical properties. The mechanical properties such as hardness, elastic modulus, fracture toughness, scratch resistance, fatigue strength are modified in a nanometer scale. An enhancement of mechanical properties is due to the modification in the size resulting from the structural imperfections such as dislocations, microtwins and impurity precipitates. The enhanced mechanical properties of nanomaterials could have many potential applications such as mechanical nanoresonators, mass sensors, flexible conductive coatings, wear resistance coatings, tougher and harder cutting tools, etc. So the mechanical properties means strength, mainly elastic modulus, fracture toughness, scratch resistance and fatigue strength. So these are the some of the mechanical terms. While coming to a material, when a material is taken, the material is converted into its converted to its nanoscale. Then its toughness increases. The materials being tough and the toughness increases, and the tensile strength will also increases. Elastic modulus will also have its increases. So increase or decrement, whatever it may be, but finally resultant will be having more and more powerful than the bulk material. Okay, this is about the mechanical properties. And coming to the magnetic properties, the larger surface area to the volume ratio results in the substantial proportion of atoms having different magnetic coupling with neighboring atoms, leading to different magnetic properties. So larger surface to volume ratio, as the surface area increases for the nanoparticles, there will be a large surface area to the volume ratio. The surface area to the volume ratio will also increases, having different magnetic coupling between neighboring atoms. So that the coupling between the magnetic coupling between the neighboring atoms also changes due to the reduced in the size. The particles, the gathering of the particles will be more and more in a small area, so that it can have the magnetic properties it can have an alteration in the magnetic properties. The bulk materials usually form simple multiple magnetic domains